Hi there, Doug Milburn here. I am president, co-founder, and I guess resident old guy at 45Drives. And I'm here with the always interesting, enthusiastic young guy.
I don't know, middle age, I would say, at this point.
Mitch Hall. Welcome, Mitch Hall. And look, we got a video. I hope you're going to find it interesting because I really found this interesting, and it's something that's been talked about lots. And anyway, when you actually do it and see it, it's really, really cool.
Yeah.
So yeah, and by the way, I asked to be on here because I'm going to do a little rant in a section. You'll understand it when I tell you what we're doing. Okay, we are going to talk about anybody who's a Star Wars fan.
Yep.
The Empire, I'll call it the evil Empire, just that little edge in front of it. And there's a guy who runs the evil Empire. You think of Star Wars as Bill Gates? Oh no, wait, it's Darth Vader.
Yeah,
oh wait,
Vader,
okay, yes, you got who we are.
They're pretty similar these days, I think.
pretty darn similar. So we're going to be talking about Microsoft Windows Server, and on one side, and on the other side, there are the good guys. There's the Rebellion. There's Linus Torvalds with his very good friends, Princess Leia and Luke Skywalker. So the really, really good guys.
Yep, that's right.
And and what we've done is basically set up a storage server. I'm going to get Mitch to tell you all about what we've done. We are going head-to-head performance, storage performance of Linux versus Windows. So Mitch,
Yep.
I want you to tell us, let's just talk about the experimental setup here. Let's go through, what was the hardware that this ran on?
Yeah, let's set the stage on that. So we used one of our AV15 Storenators. It was adequate for what we needed. We only needed 8 drives for this test. So that gave us the ability to use something, really pretty much any compute we wanted. So in that server, we had 8 mechanical drives. We used 8 20 terabyte Seagate XOs. And then from there, we wanted to make sure that the compute wasn't the bottleneck. So we used some really powerful, beefy hardware. We had a 12900K in there, which is an i9 CPU. I think it has 24 cores, something really high.
Okay.
And 128 gigs of DDR5 RAM. And we used that exact server, and this is a single server configuration, and we used it both for the Linux environment as well as the Windows environment to give a good apples to apples.
Okay, beautiful. So yeah, we got our direct lanes from each hard drive straight into a motherboard that's way bigger than you need for this.
Yeah,
right?
much more,
yeah.
exactly.
Cool.
Yep.
So that's got hardware out of the way, and so now it's just all about the software. The software.
Yep.
Cool. Okay. So you had 2 different configurations. Tell us about the software configurations.
Absolutely. So we'll start with the Linux environment. We use Rocky 8.9, no brainer. We're huge fans of Rocky Linux here. On top of that, for software for RAID and file system, we use ZFS. Again, no brainer for us. And so in that arrangement, we use what's called a RAID Z2. Now, RAID Z2 is just a fancy way of saying a RAID 6. So we have an 8 drive array, 2 drives are for parity, and 6 drives are for data.
Okay. How about on the other side?
So on the Windows server, again...
On the evil Empire side.
Yeah, the evil Empire side. I didn't even like touch it. No, I'm just kidding. On that, essentially, again, exact same server, just a different boot drive. And that boot drive is Windows Server 2022. Okay. And so they do things a little differently. So they use something called storage spaces. And in your storage spaces array, you'll build a pool with the 8 drives, and then you can carve off types of disks. So we did a parity drive with 2 parity disks. So again, 8 drives, 2 parity, 6 data. So as equivalent as you can get in a Linux versus Windows.
Gotcha. So we are about as apples to apples, and almost there's going to be a twist coming in there
Yeah,
at the end of this.
absolutely.
We'll get into what the twist is, but as identical as we could. So we got an apples to apples comparison, and we're going to test the speed in that. So you guys ran these tests. What did you use? What was your workload simulation in your testing?
Great question. So again, to keep it apples to apples, we wanted to use something that you could use both in Linux and in Windows, and that tool was FIO. So FIO stands for Flexible I/O Tester. Really what you need to know is just it's a really Swiss Army tool for I/O testing of any type of storage workload. So in that workload, we had a swath of tests, a sequential streaming read and write test, a random read and write test, and then a mix of each. So you get a really good picture of your entire storage solution. So you kind of get a feel for all types of workloads.
Okay, very, very interesting. So you ran a fair bit. You got them set up, and you ran them over and over again. So you could see some patterns.
Yeah,
exactly. You got some typical numbers here.
Things you would normally see, things that I expected, right? I expected ZFS and Linux to be more performant, and so that's what we saw. I don't know. Do we want to dive into the results already?
Evil Empire.
Yeah.
Hi. I've been around Microsoft a lot. My been a technical person for years and years and years in a bunch of different contexts, and I was DOS user, and touched Unix in the old days and everything else. And I remember when Windows 3.1 came out and everything else. And I've learned to love and hate Microsoft. Okay, first of all, I'm going to give them credit. I'm sincere about giving them the credit. They were the open ecosystem. Apple was the closed ecosystem. I didn't like Apple because they sued everybody, and and they did everything they could to prevent anybody from being entrepreneurial and connecting the system and making the system better for their ecosystem. Anyway, Bill Gates, Darth, it was an open ecosystem, and they tamed it. They really brought it together, and Windows today, the environment, the desktop environment, we have a lot of seats of Windows inside the organization here, for better or for worse. We're going to be, we are got a project coming, which we'll tell you about too. When we do it, we're going to do a bunch of systematic replacements of Windows desktop with Linux desktops. Can't wait to do that. That's the story. But I'll tell you what I don't like about Windows, and it's what I don't like about proprietary in general. It's an abuse of power. So we run a company here. We got about 400 bodies in here. Pretty much every one of them uses a computer. Yep. So Windows comes along and they push their updates on you, and they jam it down your throat. And when they update everything. That's it. And when you register your Linux or your Windows, I'm talking about desktop right now. And they want you to sign in for an account, and basically this thing wants to do a phone home. Yep. We like security, number one, the idea of anything phoning home. Yeah. And I don't really trust Darth Vader fully, number one. Number two, they have jammed updates into myself, when I've had incredibly important teleconferences or Zoom meetings to go on. And I'm going, no, how about update when I want to? The taskbar. I like their auto-hiding taskbar, but then it doesn't auto-hide because they decided there's something they want you to deal with, and they want you to deal with it now. And no, I can't do the important thing. And again, Zoom meetings, it covers up the controls at the bottom of Zoom meeting, and I'm going, oh yeah, how about if you want help? Yeah, try to go get some reasonable help out of these guys. God,
yes.
And it's like, and then last one, the Windows 8. Remember the Windows 8 fiasco? Yep, and it's kind of like smartphones are coming in, and the single app in focus on a small screen, and then they just and a touch screen, and they said, yeah, touch screens like The Simpsons, eh? And I'm thinking when Mo decided to put family restaurant, that's where it's at, the family restaurant. You get, and then Homer and Barney and all the good drinkers are out at there. Like, we're business users and technical users in here, right? And we want Windows, we want multiple screens and multiple windows open, and they threatened everybody and did everything they could to make it a single. I'm going to reach up and touch my screen. And I'm going, anyway, there's my reasons I'm not a fan of Microsoft. I am really a fan of Linux and open source. You know what? We got it set up. We're apples to apples. Evil Empire versus the good guys. White versus Darth Vader versus Luke Skywalker and everything else. Cool. Let's do sequential writes. Linux. What did Linux score?
So we were about 950 megabytes a second, which is a pretty respectable sequential write test for one stream. It's a single client write. Which is pretty darn good. And on on Windows though, we were at about 696. So it was a good effort by them. But again, I expected Linux to win.
So good. Score one for the rebellion.
Yep.
Luke, exactly. Leah, cool. Linus, beautiful. How about sequential reads?
So then sequential reads. So this one's interesting, right? Because when you're testing your storage solution for reads, you're going to want to expect your storage solution to cache, right? That's a good thing to do because it's going to make your storage solution perform much better. And ZFS is the best cacher in the business as far as I'm concerned. And so we got about 7.8 gigabytes a second read performance from our Linux machine.
Okay, and how did our buddies over at the Evil Empire do?
About 3.3 gigabytes a second. So again, not a bad showing. It's faster than the disks, which we'd expect. But again, ZFS trounced them pretty good there.
Okay, so, well, trounced them good, didn't it?
Yeah.
It's more than double the speed.
Exactly.
So that's cool. Reads were more than double and about 40% faster on write.
Yep.
And so that's on sequentials. So it's a real stream of data coming out and coming out or in from the computer, and just work on that, driving those disks and
exactly.
pounding data through there.
Yep.
So that's pretty cool, and that's a really impressive win for Linux.
For Linux, for sure.
Yep.
Yep.
So let's talk about random. Okay, and we'll talk about
things got interesting.
Write and read, because everything got really, really interesting here.
Absolutely.
And you know, the Evil Empire, Darth seems to have come out on top.
Yep.
And we'll talk about why. Is this a good, honest win in apples to apples? But let's talk about the numbers first.
Yep.
Okay. So what do you get our random read for Linux?
So for random read, we ended up with 82.2 thousand IOPS. So we'll talk in IOPS terms for random read because it makes more sense. So about 82.2 thousand IOPS out of that solution, which again, we're using a lot of the cache there, which is great for read. Now for random read in Windows, this is where, again, things got really interesting. We saw in the last time sequential read, it was slower, but why is it faster this time? So now they're at 220,000 IOPS versus the 82,000 IOPS in ZFS. So almost triple, not quite, but quite a good showing there.
Okay. Yeah, and what's the throughput difference?
So for 321 megabytes a second on the random read for Linux, and then about 690 megabytes a second for.
So about double.
Yep.
Yeah, a little
a little over. Yep.
Yeah. Cool. So how's the Empire with the Death Star there and everything else? How would you think they'd be moving faster than Linux? Is there something here? And there's something funny about the number of IOPS.
Yeah.
And right, we got 8 drive array.
Yep.
And how many IOPS do we normally get out of a mechanical drive?
About 450.
About 450, and times 8 is 3,400 or 3,500 or whatever.
And even it's 2 of those would be parity, so you wouldn't even expect to get all of that. So
it should be 3,000 IOPS. So how are we getting 220,000 IOPS?
So for reads, I think it's pretty easy to explain the fact that we're caching a lot, and we'll talk about the writes too, because the writes were also very interesting here. It just seems from the outside here, and this is the thing about Windows, is you don't have all these great low-level tools that you have in Linux to really dig into how is it flushing data through the system, how is it caching, how much is it caching, how much is actually coming from the disks. So it's a bit of a mystery, but I think we have the ability to make our ARC go a lot faster. So I think while it did beat us on the reads for the random, I think we can make ZFS go a lot better with some tuning of our ARC. But the really, really crazy thing we want to talk about is the writes. So this is where they're really putting their thumb on the scale. So when we look at the random writes, we're getting about 8,400, 8,479 IOPS, or about 33 megabytes a second on Linux. But then on Windows, we're getting 690 megabytes a second, or 177,000 IOPS.
Wow.
And that is where you really start to put your thumb on the scale. So there's something pretty dastardly going on there. And
because that's not physical. You can't be getting
impossible.
that into the drive and that, in and out of the drive and that. So it's not getting to your storage device.
No.
It's just not.
And that's exactly kind of what I showed as well.
Yes, so they're so much faster, and so it's got to be caching.
Yep, we know that for sure.
And we know that for sure. Yeah, it's non-physical.
Yep.
So that stuff, you know, so caching on the server end.
Yep.
And you know, and the other thing, Mitch, that always strikes me when you do that, when you use a simulated workload,
Yes.
It's time localization of your random writes.
Exactly.
If you had a large enough scale of random writes coming in, completely separate, chunks of data coming in, and you put way more than your cache, and then you tried to, somehow
do anything.
Do anything, it's just going to fill up. It's got to wait.
Exactly.
So you need that redundancy, and and same thing on reading, right?
Yeah, that's actually a great point, because when I made a test size larger than the RAM, it completely crapped the bed. It couldn't even complete the test. So it's clearly that it's very much heavily using the RAM, and it's almost like it really depends on it in Windows, whereas Linux and ZFS has the ability to continue operating.
Yeah, no, it's absolutely fascinating. So, so then we get into this. Safety, and I look at that and I go, would you set up, like why don't we just, because you can get in and you can crank the levers inside Linux so easily.
Very
so
much
you can just set it up to write cache like crazy.
Oh, absolutely.
Why would you not do that?
Yeah. So, well, I mean, we're a storage server company. We're doing storage for businesses where data is very critical. And so I think it's kind of crazy to have the default behavior to be very unsafe. So yes, we could do it, and I could make ZFS look as amazing or even better.
But crank up write caching.
Exactly.
And it's unsafe because the power cord goes out, right?
Yep.
Power cord goes out, that data evaporates, it is no longer there.
Off into the ether, exactly.
Or anything, I've seen Microsoft crash once in a while. I mean,
the
server's good. I don't want to
twice.
crash them, but there's plenty of, anyway, then you get a crash and you got write cache full. And I guess the other way of looking at it, when we're talking about, dual parity RAID arrays, you're not wasting 2 hard drives because you don't care about your data, are you?
Yeah.
So it doesn't make any sense
to have that
to do unsafe behavior, and we wouldn't do that in that case.
No, absolutely.
Yeah.
There's edge cases where lots of reasons for people to do it, but they're in places where, like you said, data protection is not important, and you want performance, right? But,
so when you dig into that, I thought you saw something. Did they make any comments on safety or configuration? I mean, this is a default, right?
Exactly.
So they defaulted you to an unsafe configuration.
Yeah, and it's something that you have to dig into to actually go find, right? If you're let's say an amateur or a new sysadmin, this is not something you're going to go find on your own. So once you go into Device Manager and you start poking around on the disks, it tells you that write caching is enabled by default. Okay, fine. And it tells you in very clear text that this is unsafe. In the event of a power loss, you may endure corruption. Yeah. So it's there, very in plain text. So that is the default, which for a server OS, I just don't understand it. For a desktop, okay, maybe. So yeah, very strange.
Yeah, no, I find that fascinating. Yeah, and we wouldn't, as an enterprise storage company, first and foremost, we set up dual parity RAID arrays. There's a cost to those 2 hard drives. You do it for safety. To go unsafe like that would be absolutely unsafe, and the crash on it was fascinating.
Yeah, exactly. Once you went too far and the RAM was overwhelmed, it didn't know how to recover properly.
Absolutely fascinating. And again, we get to Linux, and my start in Linux, I don't know, decades ago, whatever, it was the early years of Linux. First time we set up a Linux storage server in another company, and really it just ran for, I don't know, I think we ran for, it was a year or something before I had to make a change on it. And the problem was, I said, who knows how to do that? And remember what the configuration was? We didn't write it down well enough, and it was so long we had to go learn on it. And that incredible reliability. But, it comes at a price if you want those, virtual numbers and write a small data set back and forth, leave it all in RAM. Good, but you might as well just set up a RAM disk, really.
Right, exactly.
So there we go. So let's talk. We were talking before this. We said there's a couple of things that we really want to do. First of them, we talked about, well, could we try to play with parameters in our Linux, because we can pull levers in that and see if we could get that, exceptionally non-real, virtual performance. But we're not going to do it right, are we?
No, exactly.
Because that's totally unsafe practice.
Yeah, exactly. I'm actually excited to see if I can get our random read performance on Power faster. And I'm pretty confident we can. That's one thing. The ZFS ARC is really unique because it uses its own cache, where most storage systems, this one included, uses the page cache of the operating system. So we've got a lot of tuning parameters that we can play with. So that'll be fun to do for the next one.
I mean, that's one of the reasons it's robust too, right?
Yeah,
it
exactly.
takes that over, and that's its space.
Yeah.
Cool. So we'll play with that one.
Definitely.
So if anybody's had fun listening to this part of it, Great. And then what was the other question that you guys came up with that you said you'd really like to do a part 2 on?
Yeah, so this is really where the Pepsi challenge part of the whole thing comes in, where, okay, we've identified the performance benefits, where Microsoft kind of puts their thumb on the scale, but now it's, well, what about from a user standpoint? If we have a video editor or even just day-to-day file share users, can they tell the difference between a Windows-based SMB share and a Linux-based SMB share on ZFS? So that's going to be really fun. I think video editing will be really cool to see the difference between the latency and the streaming reads and writes. So that, I think that'll be a great part 2 as well.
Yeah, it's beautiful. That's why you guys got major thumbs up from me on going and doing that. It's one of my favorite topics because you talk about benchmarking in computers, speeds, network speeds, et cetera, and people get these ideas of what the latest state of the art is, and the marketers, like Chris McGee over here is a marketer, they're always trying to push you towards the latest and greatest. We like to have a clear understanding of how those numbers connect to real performance and real experience. So you guys are going to go measure that.
Yep.
And I absolutely love it. Video editing is great. That's the sequential.
Yep.
Yeah, what is it? And we got Mr. McGee over here behind master video producer and editor.
Yep.
And he knows the agony of a slow performing system, and he knows the joys when it's all right.
Yep.
So you guys can try that. And then, then there's like the standard business user kind of stuff that less taxing, but if you got a whole bunch of them coming in your network, then last thing I'd do is sitting there waiting, that unexpected pause when you're expecting your machine to come back.
Especially if you've got lots of files in a directory and you're just waiting for that to load. So that's something we could definitely look at doing and testing.
Great. So we're hoping you people enjoyed. Thank you for watching the video. Really, really appreciate it. Subscribe to us if you want to see more of the same. And we got our follow-ups coming up. Thank you, Mitch. Always a blast doing these videos, man.
Absolutely. Thank you very much, Doug.
Thank you.